Now we will go ahead to the design part. In MIDAS nGen, we can perform the design as per British standard. We can choose some parameters, the general design parameters like the effect to length factors, which can be automatically calculated by the program, and brace lengths also. So we can select the default options right over here. And should crack check be considered or not? Deflection check also is right over here, so we can do the modification of that. Then we will go ahead to the rebars. So the material to be selected for the rebars can be chosen from here, and we can see what all diameters of bars are there with the areas and the material property for them. Then the range for choosing the diameters of bars can be set from here. We can perform the design of beams to not 13, but 16, 12, 25 would be fine. And in case of shear rebars, 10 and 12 would be fine. If you'd like to add 8, you can do that as well. There is column design. So again, these are the sizes that have been chosen. In the wall, that is select P12, P16, P20, and for the shear rebars we can select P10 and P12 and P16 probably. And then let's move ahead to the slab foundation. So we can perform the design on slab only, and we have P10, P12, P13, P16, 20, 25, no need for 32. So that is it, and we will click on OK. Now the program is going to allow only these diameters of bars for performing the design. Then there is general rebar arrangement. So clear cover can be provided right over here for all the member types. So there is beam, column, wall, and slab. These predefined values will be kept as it is for now. We can choose to have alternate rebars for the slab. So we can choose this as considered for alternate rebar and for slab, or we can consider the alternate rebar. Then which all rebars are to be utilized for alternating, we can select all of them and click on OK. Yes, material is to be changed, of course, S460, and then we can click on OK. So that is about the rebar settings and design settings overall that we have done before performing the design. Now load combinations have automatically been created before we perform the analysis itself. So we will move ahead to the design group. The design group is very important so that the drawings will get automatically generated. So here we can ask the program to auto-generate the design group. There are different levels of detailing which you can check from the online help manual, and we will move ahead to the type. Assign type, it will be auto group. It will be based on the story. You can also choose manual auto level increment, and further let us look into the naming. So naming rules are there for steel beam, RC beam, crane girder, what should be the initial name and which number it should start from, so that we can specify. Then there are sub-beam rules. So sub-beam ones are those which are not connected to the columns directly. Column naming rule, so we'll have C and write in as a prefix. Then there is wall naming rule, so W. And yes, one good part about MIDAS nGen is that you do not need to provide it any wall ID. So we have completely skipped that part. Then there is slab naming rule as well. That's all we need. So let's click on OK. The program will automatically select the members and automatically group them. So the grouping is done. We can see how quickly it is done, and we can look at the design tree menu to confirm or to select any of the design groups. So expand design group for RC, and you can expand this to see G1 and G2. So these are the two groups that have been generated by the program, and then there are subgroups depending on the story levels. So groups are generated, and now let's go ahead to the design case. So yes, one good part is we can have the program give us the rebar arrangement, or we can provide our own rebar arrangement and ask the program to check the rebar arrangement. That's about it. Design parameters. Let's move ahead to the design case. You can generate a number of design cases, and we can combine design cases as well. We're going to generate one design case for one analysis case that have been already performed. We can choose from here which all members are to be designed. So they are based on groups. We can do the selection of different members from the selection tool from here directly. Let's click on OK, and we will run the design. There is rebar auto arrangement option. If you have provided your own reinforcements, you can uncheck this option, just directly perform the design. And in case you want to compare the reinforcements that you have provided with the program determined, then you can get this option checked on. The program will automatically compare and replace if the rebar arrangement that you have provided is failing or not good. We will have the default option on delete previous data, and we can move ahead to performing the design. The design has been performed. We can see that there are no errors or warnings, and the design results tab is also open for us to view the results. Here in the design results tree menu, which is a newly opened tree menu, we can go for the strength check, double click on the status to readily identify if any member is failing. Let me undisplay the group. Okay, so we can see here in this legend that most of the design is okay. This okay means that the demand capacity ratio is within the limits that we have set, and those were by default given as 0.6 to 0.9. So we have got some economical sections here. Then further, there are some critical sections as well, which are in orange color, and those are not failing. They are critical, as in they are having demand capacity ratio between 0.9 and 1. And then there are some members that are failing, that is NG, that is going beyond 1. So we can see those. We can see those in red color. So there are slabs, and there is a shear wall at the bottom right over here which is failing. We can actually see the reason by going to the design report and getting a detailed calculation of that member. So let's click on it, and we will click on OK. Word report is generated by the program, which gives the step-by-step calculation of the member design. So there is a wall member, and its number is 98. Material used is given, all the input parameters are there. This is the effective length factor that it has calculated for our shear wall, and this is the rebar arrangement that we can see. For the vertical it is 16 at 100, and for the horizontal it is 10 at 150. So let's look at the reason for failure. Yes, so we can see here that the failure is because of the actual force and actual capacity and the bending capacity, so in the major direction. So here it's slightly failing, 1.116. Now we can choose to add more bars and check if the analysis result is okay. We can see the results in the form of table as well in the RC section tab. We can select wall force right over here, and we can see here NG not good. So let us just filter out only those which have failed. NG, so it's only one, and we can modify the reinforcement arrangement from here. So there are n rebars that we can add. Let's say 20 rebars, diameter of rebar is there, and here we can provide the horizontal reinforcement of P12 likewise, and you can click on OK. So this is the new rebar arrangement. Now let us click on redesign for the checklist, and yes, now it is passing. However, it is in critical, so 0.95 it is, however it is passing. So we can click on OK, and we can go ahead to update the information that we have modified. So it will ask to delete the design results. We can say yes, okay, and perform the design again, this time comparing the previous data that has been provided. So in this case, the program will check and then it will find out if the results are okay or not. So now we can move ahead to look at the results for all, or the reports generated for all different types of members. So let's go to the design report, and we can go for the detail, and we can create a design result for slab, which is one-way type, then slab which is of two-way type, and slab which is plate based. We can create one for the wall type of member, and we'll create one for the column, and let's click on OK. So in one Word file, the entire report will be generated, a detailed calculation sheet that can help you understand how the program has performed the design. So it's an advantage actually, because we can find out how the calculation has been done for a particular member instead of having a general format of design. So we get this PM interaction curve as well, likewise. That's a column member, and we can look at the result for the wall. And another good part about this is the references that the program has provided. So crushing of concrete, that is in serviceability check, is also done by the program. Then this is the slab design. Conventional slab design has been performed for one-way type of member. So the slab has been designed. Negative moment is a little critical, but it has passed. Then you can look at the design result for the next type of slab, which is a two-way membrane type of slab, which has automatically identified if the edges are continuous or discontinuous. So two adjacent edges were discontinuous, we have chosen a corner slab. So if you have got a slab which is irregular in shape or has got a shear wall in between, then the design will be based on the default design parameters that has been provided. So this is a two-way plate type. So you can choose if it's a two-way or one-way plate type likewise, but plates usually two-way. And the design is performed, check is critical. Yes, so this is how the detailed report is generated using MIDAS nGen software solution. And we can also get the rebar arrangements in the form of table that is available right over here in the table tree menu. So this is a table tree menu design and the RC result table. You can get the result table for the beam, column, wall and slab. You can have it for all or for selected members. So that is about the design.